Yes! It's going.
Hi everyone, I'm Fawn, and welcome to my channel. And for the very last time ever, welcome to my first video. I've always liked building things and exploring how things work. And for this video, I'm going to attempt to build a 3D printed air power piston engine, because I can. And it might just be fun. Now, I've seen a few people build this type of engine before, but I'm going to try and put my own twist on it. The first thing I want to try and torture myself with is that I want to make it tiny, as in I want it to be able to fit in the palm of my hand. A few much smarter people than me used BB balls and O-rings to control and time the airflow going through the engine. So naturally, the other thing that I want to make this harder than it needs to be is to use valves. And with making something so small using FDM 3D printers, I can already foresee that the tolerances are going to make this quite challenging. But if there's anything a naive idiot can do, it's winging something without enough experience. So, with the confidence of a chihuahua on the other side of the fence, I jumped into CAD to see what I could come up with. This is a transition. After spending nearly a year scratching my head with FreeCAD, I use FreeCAD because of its name, this is what I came up with. It's a little sketchy, I know, but this is what I was able to do without spending another year trying to make it look good. As the piston gets pushed down, it turns the crankshaft, which then turns the bottom gear. This gear then drives a belt, which drives another gear on the camshaft, and the camshaft then pushes down on the valves in an alternating fashion, opening and closing them as the piston moves up and down. So the next step was to print it all out and seeing if it all fits together.
Well, would you look at that? That's a beautiful conrod right there.
Time to try and assemble this thing. So we'll start by putting the springs into the valve holes, followed by the valves into the valve holes. We then take our camshaft and we very graciously insert it into the holes, followed by some sort of cam gear. We then assemble the crank and we attach the connecting rod to it. We just have to make sure that it spins freely so as to not lose efficiency. Next, we'll attach the piston to the connecting rod and then insert it into the crankcase and add a bearing for less friction. We then connect our crankshaft to it and we make sure that it runs smoothly. After that, it's time to slide our piston into the cylinder and checking for the movement as well. We then add our two inserts, we put the O-ring on and then we can attach the head. We then put our timing belt on, we give it a little bit of lubrication and we make sure that it is running smoothly. Testing time! I connected my compressor to it using fish tank pipe and got everything ready to do the test.
Oh, fuck. Should probably switch on the compressor. Let's see if it goes. Adding air. Still a ton of air coming off the top. Alright, well, I'm gonna have to redesign this thing.
After the major setback that was my general lack of experience and know-how, I went to bed that night thinking of any possible way I could make this design any better, and it was apparent that the cam belt and valve system that I had made just had too much resistance. As I was laying in bed, I then had the idea to use a cylindrical valve that would rotate and control the air in and out in that way. The next morning, I set out to redesign the head using 2 rotary valves to control the airflow. Naturally, I thought I was a genius having thought of this idea, but when I googled if something like this had been done before, naturally it has. I then grinded the next few hours redesigning the cam system to incorporate the rotary valve design, and this is what I came up with. But, as I'm sure you'll realize, this gear configuration is not going to work. Because of my complete lack of understanding, with this configuration, my valves would spin 9 times every rotation. Having realized my mistake, I set out to redesign it in a much better way, only to make the same mistake again. After realizing my mistake for the second time, I promptly redesigned it and printed out a new one.
So, for my hopefully final design, I decided to make all the gear ratios 1:1. So the crank will be driving a shaft that runs through the side of the engine, and then at the top over here we will have this little guy spinning the valves. So we'll have 2 valves, we'll have 1 intake valve that sits under this plate over here, and then this will rotate with the gear in between, and the timing is obviously separate on both of those. When the piston is on its downstroke, air gets let in, pushes the piston down. When it reaches the bottom, the intake closes and the outlet then opens, which then lets air out of that little hole over there.
Time to try again.
Okay, I currently have it set at 4 bar. Let's give it a go. Yes! It's going. I don't have a big compressor, so the air's running out. But it sort of works. Alrighty. Let's bump this up. Okay, so I currently have it at 7 bar. It's unfortunately the max my compressor can go to, but let's give it a whirl. Okay. Alright, it rocks. It's going. Let's try that again, but I'm going to remove these bearings that I taped onto the end. All right, we're at 4 bars again. Let's give it a go. Oh, it's going. It's going even without the weights. That is cool. All right, let's try 7 bars. All right, it's set at 7 bars. Oh, that works so well. Okay, awesome. I should have probably stopped right there, but I thought of a way to actually combine both into one single valve. So what I came up with this solution. Through this valve is a hole that goes straight into the cylinder, and on the side of this valve is a vent that either lets air in, and when it turns to the other side, it lets air out. So the air can either go in through the valve into the cylinder, or it can go up into the valve and out the outlet that's right there.
Last time, I promise.
Alrighty, new design, 7 bar. It works. I'm not sure if it's better though.
I was so happy with the result. I felt like I could build anything, and I have so many ideas of new builds that I'd want to put out. But this is a new channel and I currently have 0 subscribers. So if you feel like I do deserve it and you enjoyed what you saw, please consider subscribing, and I'll continue to make more videos like these and get much better at it in the process. As a bonus, here are a few outtakes of when things didn't go to plan.
Right, we're at 7 bars again. I printed this little cover plate over here to prevent the valves from pushing up. So let's see what it does. Yeah, I think my timing is wrong. It would be nice if I plug it in. Yeah, crankshaft issues again. Okay.
Thanks for watching.
Well, would you look at that? That's a beautiful conrod right there.